Hello. Today we're going to take a look at notes number 7 in our packet on solving system of equations. And today what we're going to do is we're going to solve word problems using two variables instead of just one. So if we use two variables to solve these problems, we're going to need to write two different equations. So once you have two variables and two equations, you can use any of the methods that we've learned this unit to solve the equations and find the answer that would work for the word problem. Now, just like any word problem, it's really important to take your time, read through the problems carefully, probably 3-4 times, to make sure that you understand what's being asked. And then you can go ahead and try to solve it. Okay? So just as a review, let's take a look at some steps when you want to try to solve a word problem. So first of all, you want to make sure that you read the problem carefully. The first time I read a problem, I like to just read through the whole thing, make sure that I just get the gist of the problem. I don't actually do anything, I just read it through so I understand more or less what's going on with the problem. Now with today's problems, we're going to identify two variables and define them. So we're not going to use one variable, we're going to have two different quantities today. So because we're going to define two different variables, we're going to write two equations. We're going to write two equations, not just one. Then obviously we're going to solve and we're going to check. And when we check, it doesn't just mean a formal check. It's going to mean like, does this problem make sense to me? Let's take a look at the first problem here. And again, the first thing I'm going to do is just read it through completely and carefully, just to get an idea of what the problem is talking about. So in the first problem, it says, Kaylee purchased 12 pens and 14 notebooks for $20. Allison bought 7 pens and 4 notebooks for $7.50. Find the price of 1 pen and the price of 1 notebook algebraically. In other words, don't graph it. Okay, so I've got two girls here. I've got Kaylee, who purchased 12 pens and 14 notebooks for $20. So that's one situation here. And then there's Allison, who bought 7 pens and 4 notebooks for $7.50. Now what I want to think about here is, what am I supposed to do here? What am I trying to find? Okay, the question is, find the price of 1 pen and the price of 1 notebook. Now typically, whatever it is that you have to find is what you want to define as your variable. So since I have to find the price of 1 pen, I'm going to use that as my first variable. So I'm going to use P. And I'm going to try to use P because I like to be descriptive. I don't want to just use X and Y. P is going to be the price of 1 pen. And I'm going to be specific. I'm not just going to say P is pens. I'm going to say P is the price of 1 pen. And then I'm going to use N as the price of 1 notebook. It's going to help me keep track of what's going on in my equations. So I want to find the price of 1 pen and the price of 1 notebook, because that's what the question is asking me. Okay, so now it's time to write some equations. So it says Kaylee purchased 12 pens and 14 notebooks for $20. So that's what I'm going to use in my first equation. She chose 12 pens, so 12 times P, whatever they cost, plus 14 notebooks, 14 times N, that equals $20. Now my second equation is about Allison. Allison bought 7 pens and 4 notebooks. So 7 pens plus 4 notebooks, that's going to equal $7.50. Okay, so now I have two variables and two equations. Now I have to go ahead and solve. Now I'm not going to graph these, also because it asks for an algebraic solution. I could use the substitution method, but I don't want to solve for either one of these variables because nothing's convenient. I'm going to use the elimination method. And what I'm going to do is I want to get either my x, or in this case p. My p variables don't have the same coefficient, and neither do the n. So I'm going to multiply both equations by something to get them to be equal. Now when I look at 14 and 4, I know that 14 times 2 is 28. And I know 4 times 7 is 28. So I'm going to find that multiple, 28, they have the same common multiple. So what I'm going to do is I'm going to multiply this top equation by 2. I'm going to multiply this top equation by 2 to get this to be 28. And I'm going to multiply the bottom equation by -7. Not +7, -7, because then I'll get a -28. So when I have a +28 and a -28, I know that they're going to cancel. Okay? So I'm going to go ahead and write my equations here. I'm going to use colored pens to show you which one is which. So in the first equation, I'm going to write 2 times 12 is 24p plus 28n equals 40. Remember, you have to do it to both sides of the equation, to everything. Now I'm going to do the same thing with my other equation. I'm going to multiply everything by -7. So -7 times +7 is -49p minus 28n is equal to, I'm going to multiply 7 times $7.50, and it's going to be -$52.50. Feel free to use a calculator. So now this is exactly what I wanted, because now my coefficients are opposites. So now that they're opposites, I can add these two together to eliminate the n variable. So now when I add these two together, I'm going to add these two equations together, and I'm going to do that right up here. I'm going to put my answer up here. I'm going to try to be neat about this. 24p minus 49p, I'm going to get -25p. The n's cancel, equals 40 minus 5250 is going to be -1250. So now my n's were eliminated. So to finish solving for p, I'm going to divide by -25, excuse me. And when I do that, I see that p is going to equal, and when I use my calculator to do this, I get 0.5. And in terms of money, I know that that's 50 cents. So I found out that my pens cost 50 cents each. Now I'm not quite done yet, because now I have to substitute it in and find the cost of a notebook. So I can pick either equation and substitute the 50 cents in. I'm going to use my first equation. So I'm going to put 12 times 0.5, or 50 cents, plus 14n equals 20. And then I'm going to use my calculator to evaluate this. This part I know is, we know this part is simple. I'm going to subtract 6 from both sides. I get 14n equals 14. And then when I divide by 14, I get n is equal to 1. So what I've learned here is that the pens cost 50 cents each and the notebooks cost $1. So I like to label my answer. So when I'm done, I like to go back to where I define my variables. The price of the pen, I've learned now, is 50 cents. And the price of a notebook is $1. So that's my answer. Now let's take a look at the second example. First, let's read through the problem. Mario has a collection of grasshoppers and crickets. He has 119 insects in all. The number of grasshoppers is 57 more than the number of crickets. Find the number of each type of insect that he has. Okay, so this problem has to do with how many grasshoppers and how many crickets. In fact, That's what the question is at the very bottom. It says, find the number of each type of insect that he has. So he has so many grasshoppers and so many crickets. He has actually 119 in all. And the number of grasshoppers is 57 more than the number of crickets. So let me start with defining my variables. Okay, so I'm going to use G. Again, I like to use descriptive variables. G is going to be the number of grasshoppers, because I have to figure out how many of those. And I'm going to use C to represent the number of crickets. Now let me go back and read my problem again. Mario has a collection of grasshoppers and crickets. He has 119 insects in all. 119 insects in all. That means if I add up all the grasshoppers and I add up all the crickets together, it's going to be 119. So that's my first equation. I know that all of the grasshoppers plus all of the crickets together are going to add up to 119 insects. So that's equation number 1. Now let me keep reading here. It says the number of grasshoppers is 57 more than the number of crickets. So the grasshoppers is 57 more than the number of crickets. So that's my second equation. Okay, so how can I interpret this? The number of grasshoppers is. I know is means equal to. So the number of grasshoppers is equal to what? 57 more than the number of crickets. So the number of grasshoppers is equal to 57 more than the number of crickets. So there are my two equations. G plus C is equal to 119, and G equals 57 plus C. Now I can choose to solve them either way. I can use the elimination method or the substitution method, but in this case it's already solved for G. So using the substitution method here would be very easy. It's already solved for G, so I can just take this expression right here and substitute it in place of G in my first equation. So if I did that, it would just be 57 plus C in place of G, and then plus C for the rest of my equation equals 119. So this 57 plus C was in place of G, plus C equals 119. This we know how to solve. We're just going to combine like terms. 57 plus 2C equals 119. I'm going to subtract 57 from both sides. So I'm going to get 2C equals 62. And then I divide by 2. And I get C equals 31. So now I know that he has 31 crickets. To find out how many grasshoppers, I can just substitute 31 in either one. I'm going to use this one because I think it's going to be faster. G equals 57 plus 31. And then when I add these together, I'm going to get G equals 88. And then even if I don't do a formal check, in my head, if I quickly add these, 8 and 1 is 9, 80 plus 30 is 110, so I get 119. So I think I've got a reasonable answer here. So he's got 88 grasshoppers. I like to go back and write it here so I know I've got both answers, and 31 crickets. Okay, so read through the problem a number of times. Define your variables first so you know what you're looking for. And then you go ahead and write two equations. Let's read through and start the next problem together, and then I'd like you to finish it on your own. So question number 3. A total of 600 tickets were sold for a concert. If the tickets sold in advance cost $25 each, and the tickets sold at the door cost $32 each, and $16,309 worth of tickets were sold, how many of each type of ticket was sold? Okay, so we've got a number of things going on here. We're selling concert tickets. So 600 concert tickets were sold for the concert. But there were tickets sold in advance. So there are advance sale tickets. And also there are tickets sold at the door. And the question is, how many of each type of ticket was sold? So that's going to be my variable. The question that's being asked is usually my variable. So I'm going to say that I'm going to change that so we can see it better. A is going to be the number of advance sale tickets. And I'm going to use D for the number of tickets at the door that were sold. Okay? Because that's what I have to find. I have to find how many tickets were sold in advance, how many tickets were sold at the door. Okay. So here, initially it tells us a total of 600 tickets were sold. That means in all the advance sale tickets plus all the tickets at the door added up to 600. So that's my first equation. Advance sale tickets plus the tickets at the door added up to 600. That's my first equation. The tickets at the door, the tickets in advance cost $25. The tickets at the door cost $32. And they raised $16,000, $16,309. Okay, so notice that this first equation had to do with how many tickets were sold. The next equation is going to have to do with the cost, the value of the tickets. Well, the ones in advance cost $25 a piece. So I'm going to write 25A plus the ones at the door cost $32 a piece. 32 times D equals, they raised a total of $16,309. So again, the first equation had to do with the number of tickets. This many tickets plus the tickets at the door were a total of 600 tickets. The second equation has to do with the value of the tickets. $25 for the ones at advance, $32 for the ones at the door, a total of $16,309. So now I have my two equations. You can solve using you can solve using the substitution method or elimination. I think either method would be the same amount of work. So please choose one and go ahead and try to solve them. And then after you do that, I'd like you to try question 4 and 5 on your own. Please complete 3, 4, and 5 before you come to class. And then, of course, if you have any questions, we can talk about it then. Thank you.